Hi guys, welcome to my channel, and today we will create system design of a search engine like Google. So without delaying, let's jump into the function requirement or step 1. So what search engine does? It provides search results based upon the entered text. And in second is we will deal with text only search here. And third will be local pages will be on priority. So this will be our functional requirement for this system. Now let's go to step 2, and step 2 is NFRs, non-functional requirements. So system has to be highly available, and it has to be highly scalable because the search gonna happen through billions of pages out there over internet. And third will be latency. So maybe 4 to 5 seconds is fine to get the search results. Okay, that seems like pretty good NFRs from this video point of view. So let's go to the step 3, and the step 3 will be capacity met. Capacity met. So this search engine will have crawler data as input. And what crawler data is? This is a collection of all HTML pages over internet. And let's assume, because we are not designing crawler here, you can watch my another web crawler system design video to know more insight of it. So here let's assume that there is like on the S3 drive all HTML pages stored as blob storage. Okay, so now especially in the search engine, what it will have? It will actually have metadata at the top of using crawler information, crawler data. And what this metadata will have, it will have information like ID, URL, the page URL, title, description, keywords, location of the web page, and last updated. I think that's what this metadata will have. So think we have the HTML pages on this S drive, and for each HTML page, we have a row in the metadata where we have all this information stored: ID, URL, title, description, keywords, and location last updated. Now we have the metadata here. So if we assume, so if we make certain assumptions here, that let's say the metadata average size is maybe 1 KB. So what it will be, if there are 10 billion pages, 10 billion, billion is 10 into 10 raised to power 9 pages, and each pages has this metadata which is 1 KB. So it will be 10 raised to power 3 KB is 1 MB, 6 is 1 GB, and 9 will be 1 TB. So this is 10 terabyte of data. So what can we have here? This is not a relational database. I don't see any relational DB needed here, so we can go for non-relational DB. We need sharding on this. Sharding because we want to implement geo sharding on this, by which the metadata information is stored locally close to the actual web page. So it will avoid lot of movement of data information over the internet and reduce the time. So we need definitely sharding, and system definitely need to be scalable. So I think we can use maybe DynamoDB here, but here we need indexing. So one option is MongoDB has great indexing, but DynamoDB will also not hold us with along with inbuilt secondary indexing in DynamoDB. We can use Elasticsearch with the help of lambda here. So basically what will happen, any insert, update or modification happening in DynamoDB, we can just have a lambda function which will keep our Elasticsearch updated accordingly. And we can maintain entire indexing in the Elasticsearch, the advanced indexing, the full text search and all those things. So I think we will go with the DynamoDB for the metadata here. And at the top of that, we will have a lambda and the Elasticsearch. So that way we can use it. Although I know Google used the earlier it was using Bigtable and then the spanner, but I don't know too much about the spanner, so I don't want to bring that up here in my system design. But just for your knowledge, I think that is the spanner DB they are using. So now we know what database we're going to use, how much data we will have here. We will have the crawler data as input here that will be stored in the S3 drive. So we did a great brainstorming around the capacity math and have a good understanding now. So now let's jump into the design. So here is user and user will talk to the search engine. Here is the searching service. And what search service will do, search service will look in the database, and that is the Elastic Search DB, and which will be having a DynamoDB, and there will be another database that will be the S3 drive, which will store the HTML pages collected by web crawler, and here we have the crawler. So crawler is continuously updating the HTML pages, and these HTML pages, there is this service here, it will be, which will be search metadata. So what it will do, it will like go through with the crawler pages and will update the DynamoDB metadata, and then the lambda function will be continuously updating the Elasticsearch here, and this Elasticsearch is actually providing data to the search service, and it will be going back to the user based upon the text entered. And on the user side there will be a service auto search complete. Auto search complete will be helping user to faster its search, and we already have a video. I will put a link for that video here so that you can watch that video to see how auto search complete works. So now let's run the functional requirement. Provide search result based upon the entered text. So user enter the text, goes into the search service. Search service look through the Elasticsearch and send back the information that yes, these are the list of pages what you can use. And now the it's text only yes, and local pages on priority. So basically what it will do, the key thing here is the indexing. How system will, how the values will be indexed here. So here we want to do location based indexing so that we can get the search result based upon the location. Like for example, if the user is sitting in United States, then the pages which are like from the United States are coming at the top in the search results. So location based indexing. Second will be URL index based indexing. So if someone is simply searching abc.com, then the URL based indexing is helping to quickly reach onto the results. Keyword based indexing. So how it will work? Let's see now. So all the indexing will be in place here. Now, when the user sent a text and it comes to search service, what it will do? First clean up the search text by removing not needed words. For example, if user had searched best restaurant in Allentown, so it will remove in from the search. So it will remove all these not necessary words from the search query. Second, it will perform spell correction. And then once I have the final list of keywords, it will look through the keyword indexing and pull out pages which are which have the searched words. Now, once that has the list of pages, it rank pages. And how the ranking works? Basically, ranking is based upon the uh, freshness location. If it is local page, we will keep it high ranking. Then freshness, the recently updated page should be on the high priority. And there are other factors also, like if the word is search word is in the title, right away in the title rather than the down there in the text, then it will be high ranking page. Like there are like multiple other options. So based upon these parameters, search engine basically rank the pages and then pick the higher ranked pages, higher rank pages and put them in order on the search result page. So that's how it actually works. So the local pages will be on the priority because we will implement in the ranking to take the pages which are local on high priority. Now in terms of NFR, highly available. So database side we are pretty good, but the service definitely need to be horizontally scalable. And what we need to do for that, put here a service. So gateway service will be here, which will be taking care of auth, redirecting, rate limiter. Here will be the session service. And because this need a load balancer here, so now our system is highly available, highly scalable, and 4 to 5 seconds to find the results, which seems like pretty reasonable from this design point of view. So I think looks like a good reasonable design guys here. So guys, thank you so much for watching this. Please leave your feedback in the comments and don't forget to subscribe the channel. Thank you so much.